Hello and welcome to today's webinar on sampling do's and don'ts. My name is Peter Behor from the U.S. Environmental Protection Agency's Office of Compliance Water Branch. Today's speaker, Cornell Gale, assisted by Chris McHugh. Cornell works out of the U.S. EPA Region 4 Atlanta office I mentioned. He's a licensed professional civil engineer with the state of Georgia and provides support to states and local municipalities, ensuring compliance with the NPDES requirements, and recently changed jobs and is now currently working on ensuring inspectors are properly trained and credentialed to the U.S. EPA Region 4. Chris McHugh received his BA in agricultural engineering and an MS in engineering from the University of Georgia. Chris started working in July 2016 in Science and Ecosystem Support Division, Athens, Georgia. Chris overviews audits of the Region 4 states and conducts inspection training with other Region 4 inspectors as requested by the states. Chris is an avid golfer and enjoys playing when he gets a chance. And I'm handing it over to you, Cornell and Chris.
Thank you, Peter, for that introduction. Peter mentioned in the introduction, we're going to talk about when you should sample, where you should sample, the general rules of sampling. And here, this presentation, some of you have seen it before. For some of you, this will be brand new. We're going to cover some of the NPDES regulations. We're going to review composite and grab sampling requirements. We're going to, not today, but normally if we were in the classroom, we would do in situ measurements as well. We're not going to cover those today. What we are going to talk about sample documentation and common deficiencies when you sample. Okay, so regulations. We all know that the permit, the NPDES permit, your state and local permits, those are your guidelines. As an inspector, my job is to make sure that you follow the law. Point blank, period. It's not to impose my will. It's not to impose my feelings. It's not to impose any of that. Your job is to make sure you follow the law, and it's my job to make sure that you follow the law. And that law is typically your permit. That's your state permit, or if you're a tribe, your direct issue permit. Then the permit's normally backed up by 40 CFR. You have parts 122 for record keeping and parts 136 for sample handling. And if you look at parts 136, normally they refer back to an ASCE standard, an ASTM standard, or typically more commonly these days, you'll have standard methods, the 23rd. They're now in the 23rd edition. So if you have a 20th edition or a 21st edition or a 22nd, hopefully you don't still have the 19th or maybe not the first edition on your shelf. If you have the first edition, it might be a collector's item at this point. But you want to make sure you're following the current standard method for whichever sampling method or sampling routine that you are running. The general requirement for sampling, the whole point of it is that it must be representative. So imagine you go into Sam's and they give you a sample of one of the drinks, and you buy that drink and you go home. You fully expect that that drink tastes the same as the sample that you collected. And if it tastes different, you're going to want to take it back. Well, this is the same thing. Your sample should be representative of what you're actually sampling from, your larger pool. So if it's influent, your sample should be representative of your influent. If it's a process sample, your sample should be representative of whatever tub, vat that you're picking up from your process, and the effluent likewise. The procedure must meet permit requirements. If your permit says it has to be flow proportional, then it must be flow proportional. No matter how wrong you think that is, no matter how faulty you think it is, no matter how you feel about it, if the permit says flow proportional, it must be flow proportional. If your permit says that you must do a manual grab sample every 15 minutes for 24 hours, that's what you must do. It'll cost you a lot of money because you'll probably have to hire somebody to do it, but that's what the permit says. And again, it's my job as an inspector is to make sure you're following the law. And hopefully none of your permits say manual grab sample for 24 hours. That's why we have automatic samplers. Then the third component, the container. You must have the correct container and preservation. If you are sampling semi-volatiles in a plastic container, then you have just contaminated your sample. The reason the containers are specified and the preservatives are specified, they are specified so we can make sure that we're getting, again, this goes back to rule number 1, representative sample. By putting the wrong, or by using the wrong container, you're introducing all kinds of contaminants, or what would be a contaminant, into that particular analysis. Or in the case of oil and grease, you just can't run the sample because you would end up dissolving. If you took an oil and grease sample, which is in a glass jug, and you put it in a plastic jug, when they go to run the sample, you'll end up dissolving the plastic because of the process by which they use to extract the grease out of the container. So again, proper container, proper preservative. And usually you'll find out that, where was I going? Usually you'll find out that when you don't sample correctly, it only hurts you. It only makes your numbers, it only moves your numbers in the worst case direction on your permit. And we know if you overestimate or underestimate based on how your permit is written, that means that you could be subject to fines or other negative consequences. So general requirements. Samples must be representative, they must meet the law, and they must follow the standard methods, which is akin to, again, meeting the law. Automatic sampler uses, same thing as grab sampler. Automatic samplers, they just save us time, save us energy, save us manpower. The automatic sampler is there to sample sometimes in difficult locations, sometimes when we need a frequency of sample that is beyond what we can get. So I can tell you, typically at the EPA, we sample every 15 minutes. Imagine if someone had to stand out there and again, take that sample every 15 minutes to get a representative sample. That would be a poor use of time. So we use automatic samplers to sample different treatment units, to set up multiple sampling events at different locations to get different types of composites or different types of representative samples from different portions of a process. Again, they save us manpower, they save us time, and hopefully that equals saving us money. Was there a question that came up? All right, I'll keep going.
Well,
Go ahead.
Cornell, there was one quick question. Was someone was asking how do they get the CFRs? I responded they're online, but you might want to add something to that.
So yes, like Peter said, the CFRs are online. Make sure when you search for them, you search for eCFR. You don't want to search for CFR by itself. You want to search for eCFR, the electronic version of the CFR. Automatic sampler uses. So here you're looking at on the right. We'll start with the photo on the right. You'll see there, that's the base of the sampler, has multiple containers. We could use this to do flow proportion sampling. We're going to talk about that here in a minute, where you put the same volume in each one of those, and if you measure your flow, you can proportion it out into your larger composite container. In this case, we used it to try to identify what's going on in a process. So if you look at the picture on the left, you'll see in the top left, that's the flow meter on top, and the sampler is on the bottom. On the bottom left, it was all lowered into a manhole. We had a facility which was discharging at night when they suspected no one was looking. So we put this setup in the manhole, and we took a sample I think it was every 30 minutes. And so if you look at the picture on the right, you'll see that there are 4 or 5 containers that are darker than the rest. They have fluid in them. When those were analyzed, we could see that they were discharging things that they should not have been. In other words, they were in violation of their permit. Well, if we had a huge composite sampler and all of this was blended in with their normal daily sample, you wouldn't be able to identify this because dilution would have been their solution. So here we wanted to know what was going on at a specific point in time, and we use this. And I don't know about you, I've been in a manhole before. It's not very comfortable, and I would rather not spend overnight in a manhole. So we put the sampler down there that did the work for us. Other uses you might use it for at your plant. Let's say you have a slug or a facility industry that's sending something to you, and you just don't know what it is, but it's causing problems. And you think it's happening between this time or this time, you can do the same thing. You can set up a sampler like this and have it take a sample once an hour, once every 2 hours, just to get an idea from your influent what's going on. If you want to know how your effluent or how a process is behaving over time, again, this would work also. So I see a question here. What is the standard of a container for influent and effluent? Is plastic or glass good? So we're going to talk about this some more also, but typically you see plastic. But again, you have to follow what's in your permit. If your permit says that you have to sample for something, and there's a table for this in the notes, we're going to get to it. If you have to sample for something that needs glass, typically it's going to be your semi-volatiles. If you have a semi-volatile sample that you have to take, then you can composite it, but that must be a glass container. So again, talk to your lab about what container they require, and then go from there. But typically we see plastic because in the wastewater world, we're mainly dealing with nitrogen, phosphorus, BOD, TSS, things of that nature that don't require a glass container. So different types of sampling. Here you have your composite sample. On the left, you have your grab sample. A composite sample is nothing more than a series of grabs. And your grab sample is a series, could be a series of smaller grab samples. So what do you mean by that? Well, the rule is any sample you take within 15 minutes is one sample. That's one time. And this is why when you go out to your effluent and you have to take a sample for fecal and you have to take a sample for TSS and you have to take a sample for all these other things, they all have the same time on the jar because you're doing them all within 15 minutes. So let's think about this in terms of sampling in a open channel water body. The river's flowing past you. You're standing in the middle of a river. It's flowing past you. Now, I haven't mastered my God complex yet, so I can't snap my fingers and stop time and stop the water. So I can have a block of water around me and I can get all my samples from the same block of water. No, I can't do that. And I don't know anybody who can. That water is constantly flowing past us. So the rule is any sample I take out of that water body in the same location in 15 minutes, that counts as one grab sample. Okay? And then if I take a series of grab samples and put them in the same container, so I take a grab sample 15 minutes, I wait 15 minutes, take another one, I wait 15 minutes, take another one, another one, and I put them all in the same container. Now that is a composite sample made up of all my grab samples. And on the left, you're looking at a refrigerated sampler. So far you've seen in this picture here, you're looking at a portable sampler where on this one, the ice would go in that cavity in the middle. You'll see some more in the future. The ice may go around the jar on the outside. This one here, that is basically the same pump that's on top with an igloo cooler. I'm not an igloo cooler, with a Magic Chef cooler beneath it. Whereas this one is more of the same pump on top with the igloo cooler beneath it. So composite sample, we talked about this, collected over time. It represents the average wastewater characteristics during the compositing period. They're both portable, refrigerated. And they even make portable refrigerated ones, even though it is debatable how portable they are because now you're lugging around a compressor. They put them on wheels. They're still could be pretty hefty to lug around. But if you are in Mississippi or in the plains in the summertime where there is no shade and the sun is just having fun with you, then it may be worth it to get that. that type of sampler that comes with the cooler or the refrigerator built in to keep your samples nice and cool. So types of composite samples, you have time and flow proportional. Time is what we've been discussing. It's when you take a sample at a regular time interval. So when I said 15 minutes, wait 15 minutes, take another one, wait 15 minutes, take another one, that would be your interval, 15 minutes. That's as close as you can get without having a continuous sample. Because remember, within 15 minutes, it's one sample. So typically, when the EPA comes out, this is what we like to use. This is the bare minimum right here. So it works because you have a steady flow. You don't have wild changes in your flow characteristics. That's when time compositing works best. Now, if you have an industry which produces product A in the morning, product B in the afternoon, and product C, and they do a washout in the evening, and all three of those products have different characteristics, then and they have different flow patterns, then you may need a flow proportional composite. And what a flow proportional composite is, it's a sample based on the flow that passes in a current time. So I was at a facility and they basically had a vat. So this was like a batch reactor. They had a container that they held all their wastewater in. And when it filled up to a certain amount, they neutralized the pH, they opened the valve, and they flushed it out. Well, for most of the day, there was no effluent flowing. So if I was doing a time composite, I would be sampling nothing because the channel was dry. And because of the speed that the flow was coming out, if it came out in between my sample points, my timed sample points for my time composite, I wouldn't sample anything. I wouldn't get anything. So this is why it's important to know as a regulator what kind of facility you're going to so you can be prepared with what method of sampling. That facility required flow proportional sampling. And it required it required us to actually do a grab sample because of the volume. They were in low flow production, and the volume that was coming through it wasn't sufficient for any type of composite sampling. So again, flow proportional is a sample based on the flow rate, whereas time, it's regular spaced time intervals. So two common methods of collecting flow proportional samples. You have your automated flow proportioning. This is where we set the flow meter to tell the sampler when so many gallons of wastewater have passed. So if I want a sample every 10,000 gallons, every 100,000 gallons at a larger plant, it might be every 150 or 200,000 gallons based on the size of the plant. Then the flow meter will tell the sampler, hey guy, I'm ready for you to take a sample. It doesn't tell it how much flow has passed because that's the flow meter's job. It just tells it, take a sample. The flow meter knows, you program the flow meter to tell the sampler how frequently to take the sample. And that's how that works when you have an automatic sampler paced by a flow meter. Now, when you are doing it manually, that's what we saw in the pictures earlier on in this presentation. You see the carousel with all the individual bottles. So what we would have done if we were manually doing it is I would go out, or I would look at my chart readout and I would say my sampler is set to take a sample every hour. So I have one 200 ml or 1 liter sample every hour that I grab. And at the end of the day, I have 24 of these bottles. And I know for every hour how much flow has went past my plant or how much flow correlates. And then from there, there's some math that we're not going to do today. And basically you ratio or you proportion it out to say 10% of my flow happened here. So of my total volume, this one container, hour number 1 is 10%. Hour number 2 might be 20%. Hour number 8 might be 0%. You proportion it out based on the amount of flow that has gone by in that duration for that sample. Your samples might not be 24, they might be only 8 because your permit says you have to do an 8-hour composite. And so now instead of 24 bottles, you're only splitting the flow up over that time, not the entire spacing of the plant, but over that time. So automated flow proportioning. So here you can see on the left, you have your refrigerated sampler, and on the right, the guys are bent over the flow meter. And basically they're programming the flow meter to tell the sampler to take the sample. So those are two components you need. You have to have the flow meter and you have to have a sampler. And then manual proportion, just as we said, you have your sequence of bases, or you can do this manually. You can manually go out and do a grab, put a lid on it, stick it in the fridge, manually grab, stick it in the fridge, so on and so forth. And then you have your recorder, and then you can read your recorder to know when I grab this sample, this was the flow. When I grab the next sample, this was the flow. And the difference between them is the amount of flow that went past in that particular period of time. All right, let's take a question. Let's see, I saw one earlier. Somebody asked, how long does how long can a sample can a sample stay in the cooler? Can it stay in the refrigerated portion of the sampler? Well, that's also going to be based on what you're sampling. So remember, if that refrigerator is refrigerated correctly at less than 6 degrees C, it is preserved and it can stay in there. Again, it's based on what you're sampling. If it's BOD, then it's only going to be a certain amount of time. If it's metals, then it's going to be a certain amount of time because there's different preservatives. If it's nitrogen and phosphorus, it's a certain amount of time because there's different preservatives for each one of those. Some just require ice, some require acid. So I personally, again, this is not law. When your 24-hour period is up, pour your samples up, preserve them properly. That way you have a bottle of BOD or TSS, you have a bottle of nitrogen and phosphorus, you have a bottle for your whatever next, or a bottle for whatever's next. And all of those will have different preservative or different holding, these are called holding times, different holding times. So I can't recommend that when your sampler is done, you leave it sitting in there for a week. But based on what you're sampling for, talk to your laboratory. You might be able to leave it in there overnight if your sampler finishes at 2 a.m. and the first guy doesn't get there until 9 a.m. That might be fine, but it's going to be based on what you're sampling.
Cornell, I have another question. I have another question for you from the question box. Carrie Neal asks, if you're conducting a compliance sample of a permittee with flow proportion 24-hour composites, does EPA also do flow proportional, or do you do time due to sampler constraints?
So if the permit says, it depends on what we're going for in the permit. If, let's say it's a batch reactor with irregular flows, then EPA really should be using flow proportional sampling. To get, again, the goal is to get a representative sample. So to get that representative sample and not sample dead space, it should be flow proportional sampling. If we are trying to enforce a permit, that's different. If you're enforcing a permit, then you should follow the permit. So in that case, I would say flow proportional because you're enforcing a permit. And you can't readily say that this is a perfect match 1-to-1. And I say that, again, it's depending on the type of plant. Because if you are at a traditional mechanical plant where you have steady effluent and it says flow proportional, there are studies, and I just completed one or completed the draft of one that say If you sample at 30-minute or 15-minute intervals, so the closest, again, 15-minute intervals, that's the gold standard. If you sample at 15-minute intervals at a mechanical plant, the results are almost identical to that if you were to do flow proportional sampling. So again, flow proportional sampling really should be based on application. It's not necessary at uniform plants with uniform flow, unless they have swings in flow. And we're talking about really, dead times or high I&I. Then you might need flow proportional. But again, to answer your user's questions, the question, if the plant was a batch reactor, something like that, and I want to enforce the permit, then I'm definitely going to follow the permit to give my case the best possible chance in court.
Thank you, Cornell. If I could, I'd like to ask one more from Patricia Zarmez.
Sure.
She asked if you could tell us what the make and model of the portable flow meter was that you used in the example.
So there are two different examples. In the first one, that was an ISCO flow meter and sampler. And in the second one, that was a Hawk one. Those are the two major brands. Hawk gobbled up a bunch of smaller brands in the past, in about 5 or 10 years ago. But Grayson or Graco, I think that's not the sprayer company, but a different company. They also make samplers. So we don't endorse any particular company, but those I've used both of them and they both work great. They have similar features. You can't go wrong. And here you can see that brings us to our automatic composite sampler. So 3 types. You have your portable or refrigerated ones. Those are all the ones that you've seen before. That's the one we're going to show in the demo this afternoon. They all have peristaltic pumps. What a peristaltic pump is, it's basically 2 wheels that rotate and they squeeze the tube. And by squeezing the tube in a pattern, they create a vacuum or a suction. Downside to peristaltic pumps is that they are limited in the amount of head that they can pull. So they can pull up to between 20 and 27 feet of head. And it is a hard stop. And I say between the two because it's going to be based on how long your tubing is, the diameter of your tubing. There's some factors in there that will decrease the amount. But they are really limited in that aspect. So if you have a really deep wet well that you're sampling from, or your water level drops below 20 feet, 25 feet, then really be careful with a peristaltic pump. And it is a hard stop. I broke my heart once. I set my sampler, I went to run it, and I watched the water come up the tube, and it slowed down, and it slowed down, and it slowed down, and then it stopped. And all I needed was an extra 6 inches, and I couldn't get it. So that is something to look out for with peristaltic pumps. Now you have pneumatic and vacuum assisted samplers. The thing about the pneumatic samplers, they're designed for smaller flows. So it's not smaller flows, smaller volumes. We're talking about less than 40 milliliters in that range. So if you're taking a lot of samples, again, in wastewater, we tend to need a lot of volume for our samples. So we use the peristaltic pumps more commonly because they handle solids better, and we can sample. They're really accurate when you're greater than 50 milliliters and really above 100 milliliters. They're accurate with the volume that they sample. But if in your case you need and they have fewer parts to wear out. But if you need a vacuum assisted sampler for your purpose, and you're going to take a lot of smaller samples, less than 40 milliliters, then a vacuum assisted pump is for you. And then you have continuous automatic samplers. These are important if, for any reason, the location that your sampler is in is far away from where you're sampling from. So in this case, you have a piping network which basically pumps from your sampling source to the sampler. And this is going to be in a 2-inch or greater pipe if you're on effluent, probably 1 inch or greater. And that's going to be because it needs to carry the solids also. Again, we want a representative sample. So if you're sampling the influent and you have to pump it to your sampler, you need to be able to get those solids and move those solids. You don't want a strainer on it because now it's not representative. So let's look at what these look like. Here on the left, somebody asked about types. That is a Hawk. That's an older Hawk sampler. And you can see it's a refrigerated version. The refrigerator's on the bottom, the pump is on the top. Again, that same pump, they take that and they put it on a cooler like what you see in the image on the right, which is an ISCO sampler, and now it's portable. And so on the right, you can see the portable sampler. Again, same pump on top. You can see the 2 wheels that rotate, and then the cooler is at the bottom. Here's a vacuum assisted sampler. So basically, I think there's like 3 steps to this. The first one is it pulls the vacuum, which clears the line, and then it fills up the volume container. It opens a valve, releases it, and then when it pulls the vacuum, it clears the line again, wash, rinse, repeat. Again, more steps, but notice this is taking a smaller aliquot. So it's less than 40 mils. That's where it likes to live. And then here, this is a continuous sampler. So it's basically a floor model. It's refrigerated like the ones we've been seeing previously. And on the left, in the top of it, there's a housing where water is continuously pumped into it. So wherever you're pumping from, that's continuously pumped into this upper chamber. And that arm that you see, it dips down and up continuously. And it takes about 5 to 10 mils at a time. And it just continues to dip down and up, down and up, down and up, down and up, down and up continuously until it gets to the sampling period is over. And then here you can just see this is the way it's programmed here at the top. This is the automatic sampler. You can program it however many times you want, so on and so forth. Components, you can see underneath it, that little white dot or the white area in the middle of the top, that has the tube, and it also has what's called a float. So basically, if the container gets too full, that float will push a sensor in the pump that tells it to stop pumping. This way you don't pump your sample out when it purges and then put the same amount back in when it goes to collect the sample. So that's the whole point. And in here, that's a 4-gallon plastic bottle. We like the 4-gallon plastic bottle because when we sample at every 15 minutes, excuse me, not 15 minutes, when we sample 100 or 96 samples, that's one sample every 15 minutes, that gives us enough space to hold all of that liquid. And we're generally sampling somewhere between 105 and 125, 130 milliliters per aliquot. That means every time that sample runs, it's pulling between 105 and 125 milliliters. And again, every 15 minutes for 24 hours. Here is the strainer. You're going to see this later on. And then what this does is basically those holes are slightly smaller than your intake tubing. And this just helps to keep debris out of your tubing. However, it does like to collect stuff. So for those of you who put this in your influent, you know you're going to collect rags. This is going to be something you're going to clean on a daily basis. All right, do we have any more questions, Juan or Chris?
My computer crashed, but I'm still on the audio on my phone. Someone earlier asked a question about the maximum height that you can pull a sample from. Like, let's say the sample collection point is 30 feet below grade.
So that is, again, limited to, but based on your pump diameter tubing, for a peristaltic pump, it's going to be, I think it's 26.5 feet. And there's some math behind why it's 26.5 feet, has to do with atmospheric pressure. But again, a lot of it depends on the diameter of your tube. and the length of your tube, because you have a lot of friction losses there. Because your tube can run horizontally along the ground before it goes vertical in a tank for a distance, and you will lose pumping distance or pumping head also. So again, to be safe, if it's deeper than 20 feet, I would not use a peristaltic pump.
And one more quick question.
Okay.
What happens if you show up the next morning and you find out your sampler stopped at midnight?
Well, then you got to do it again. You have to ask yourself, is this representative? If it's not representative, then it's not worth it, and you have to do it again.
Okay. And I have a question too, and also I've had my sampler fail, and you just have to do it again. I have a question from a Mr. Adeboale Sanwo. If your flow is intermittent and you're using a flow proportion sampler, how does 24 hours work?
So if your flow is intermittent, generally the facility will know how much it discharges in 24 hours. It will have those records. And you go back and you look at the records. And so now this is where your inner Merlin comes out, and you're trying to predict the future. So you're going to say, I'm going to take this anticipated volume divided by 100 or 96, because for us, we're trying to get 96 aliquots. And that's going to tell us the amount of flow that we need to sample in. So because it's intermittent, let's just say that broke down to every 10,000 gallons. Well, that 10,000 gallons might go through in 15 minutes in the morning. So I get 4 samples in the morning, but for the next 3 hours, I might not get anything. But then it picks back up in the afternoon. And so now I'm sampling back to back to back to back to back to back to back. And then before it tapers off again. And that's the purpose of flow proportion sampling. So you're taking an estimate of what you expect the flow to be, and you're applying that to what your current program is. And that's one of the advantages of taking the sample, taking 24 or however many individual samples, and then flow proportioning them after. Because instead of trying to predict what you have or what's coming in, you are now looking at what actually went by.
Cornell,
Okay.
I have a couple of questions.
Okay.
Hear me right? How do you determine the sample collection time from the start of the composite or the end of the composite in order to determine the holding time?
So I normally use the last sample on the composite as the start of my holding time. That's just what I use. Some people would like to use the first one. As long as you're consistent, be consistent. So you shouldn't be running your samples that close to your holding time. That's not a good practice, because if you get into an accident or something happens, you don't want to have a sample that is wasted.
So I have another question for you. Does the preservative time start once the composite sample is completed, or at the start of the compositing process?
So that's the same question as the last. Be
Yeah.
consistent. Be consistent. That's the driver. Be consistent. Now, you do have, from the time the sample is poured until it gets to that -6 degrees, you do have at least 2 hours. Within 2 hours, it's considered in cooling or in the process of cooling. If you're transporting it and you get it to the lab within 24 hours, it may be flagged, but you can say it was in the process of cooling as long as you can show it was always consistently on ice. But beyond 24 hours, if your sample is not below 6 degrees C, it will be flagged as not within temperature or not within the preservative temperature. It's like having it out of preservative. Buffers only last so long inside a sample. So we do want to collect our sample in our composite sampler and dispense it and get it to the lab as soon as efficiently as possible. So let's keep going. Talking about containers.
You want more questions? You want to move with the?
No. I want to keep going.
Okay.
So we have
Okay,
two types of containers. On the left, you're looking at a glass container. On the right, you're looking at a plastic. Again, it says organics on the slide, but you cannot collect organics, volatile organics, in through a peristaltic pump, because volatile organics will be lost through the suction action of the pump. Those have to be collected directly in the container, which they are taken, and there are methods to do that. So when we're talking about automatic sampling, you can only collect semi-volatiles. And for those, you would definitely use a glass container. And then for your inorganics, your metals, you can use the plastics all day long. And so here, we want to make sure our aliquot volume is the same. So again, that 100 milliliters that you see on the right, that refers to a peristaltic pump. Remember, its sweet spot is really greater than 100. That's where it's the most accurate. It'll do greater than 50, but it's really accurate when it's greater than 100. And over my 8 years of sampling, I find even at 100, it's plus or minus 5 mils. So when I go and do an inspection at a facility and their sampler is set for 100 mils, chances are I might get less. And if I get less, then I have to write that down as does not meet the minimum 100 mil sample requirement. Even though I might take that same grab sample 2 or 3 times, one of those times it's gonna be less. So I always recommend that you collect a minimum volume of at least 105, because the rule says 100. And so make sure you're always within compliance with the rule, definitely just go with 105. That extra 5 mils shouldn't hurt you. We can put it back in the treatment plant and treat it again if you like. And then when you split a sample, or when you're sharing a sample, you're pouring a sample up, it's in a large container. Again, gravity takes effect, the solids sink to the bottom. Anything that's light floats to the top. You want to put a lid on it and shake it up really good. As long as you're not doing volatiles, you want to shake that container up really good. Make sure you get it evenly dispersed. That way, when you go to pour it up, you're getting a representative sample. You're not letting all the solids settle to the bottom and decreasing your solid count. Because when your inspector comes or your regulator comes, they're going to shake it up and they're going to see it. Your sample has more solids, and they're going to ask, well, what's going on here? So let's review. The method should be permit requirements. Proper refrigeration, less than 6 degrees C. Suction line should be well positioned, midstream, mid-depth. Now, we really didn't touch on this before, but I will say, if your suction line is against the wall, what lives against the wall of your tank? Well, that's where all your solids settle. That's where your algae grows. So all you're doing is running the risk of pulling in a chunk of algae, pulling in more solids, pulling in more grit, and that increases your solids count in your analysis. Well, what does that do? That means that you are artificially trying to, on the front end, get rid of more solids, but on the back end, you're saying to your regulators, hey, I have a lot of solids here. Go ahead and fine me for exceeding my total suspended solids numbers. So do yourself a favor, midstream, mid-depth. You want all the solids to be at the bottom of the tank, away from your suction line, midstream, mid-depth, because that's going to be representative of what's going out the plant. There's a purge cycle. So when you run your sampler, before it takes a sample, you want it to purge. That's a good practice because, like you'll see later on, if you're like in a sunny state, especially in the summertime, algae grows in these tubes like crazy. And all it takes is a little bit of water. So you want to rinse this tube out before you take your sample, because the last thing you want to do is go to take your sample and now you clean the sample tubing into your sample container. And then your proper intake velocity needs to be 2 feet per second. It needs to be 2 feet per second because we know at 2 feet per second, solids stay suspended. Now, how can you measure this? We really don't. So I'm gonna give you a tip there. You know, unless I'm looking at a homemade sampler where I have to go back and call the manufacturer, and I have done this and I continue to do this, I will call the manufacturer of the pump and make sure that the pump operates as it should and so on and so forth. I normally listen to see if the pump is in good working order. Because if the pump is in good working order, Hawk, ISCO, Grayson, they all know that 2 feet per second is the gold standard, and they normally shoot higher than that. And then your proper tubing size. It must be 1/4 inch ID, that's inner diameter, a minimum of 1/4 inch inner diameter. And based on what you're sampling, you either need Tygon for inorganics and metals, or you can use Teflon for your semi-volatiles, your organics. And so we will look at your permit and say, based on your permit, this is what you're sampling for. This is the tubing you need. Remember, Tygon is more common. That's the soft, squishy stuff. And Teflon, you know, think of the Teflon Don. That's how I always remember it. It's really hard stuff. It's not brittle, but it is very stiff. And if you're, again, I can say southern states because I work in a southern state, the sunshine will take the Teflon, will take the Tygon and make it stiff like Teflon. It will dry it out. And so that's something we do check when we check the Tygon tubing. We want to make sure that it is malleable, flexible, rubbery, and not stiff like Teflon, which means it's heavily degraded. And that degradation, that degradation ends up in the sample and can affect your outcomes. And then the aliquot, at least 100 milliliters. We talked about this previously. Are there any questions? Let's get 2 or 3 questions.
Unless Juan has something, I'll jump in. I'm just picking random. Go ahead, Ron. Juan, do you have something?
Yeah, I had a question. Can you go first, Peter? I need to find it again.
Does the composite sample need to be taken from midnight to midnight?
No, it does not. It's based on your permit. So if your permit says 24 hours, then you can start it at 2 p.m. 24 hours is 2 p.m. the next day. Now, if your permit says midnight to midnight, then follow your permit. Some samples say 8-hour composites, and then you can start at noon and end it at 8 p.m. or any 8-hour period of the day as specified by your permit.
I'm gonna, Juan, did you have one, or I'll just go?
Go, Peter, go.
This is just a comment. I keep the sample event marker turned on with my ISCO sampler to verify the actual flow is happening when the event happens.
So what that means is ISCO will give you a readout of if it missed a sample. And so that sample event marker tells the user if it missed a sample or how many samples it missed. And by missing, that means no liquid passed through and was deposited into your container.
I'll keep going as fast as I can. Are there any concerns with using an auto sampler to flow composite for BNA, base neutral acid analytes, then pouring off after 24-hour sample period and preserving as necessary?
I'm not sure about that. If you send me an email, I can look that up and get back to you. All right, I'm going to keep moving.
Good.
So grab samples. Again, we talked about this as an individual sample collected over a period not exceeding 15 minutes. The whole point is to collect a sample that's representative. Do it efficiently and quickly. So here on the left, we're collecting from the aeration basin. On the right, we're collecting from the chlorine contact chamber. So on the left, there's a giant bucket. That's just like a bucket with a string attached to it that you would get at the dollar store. It gets the job done. It's fast, it's easy. On the right, you'll see this in the next photo, but he's got his amber bottle. He's collecting his semi-volatile sample directly in the bottle from the effluent chamber. And so here you can see it's a metal conduit. Chris is going to show you one that's plastic or fiberglass. They come in all shapes, but anything that can safely allow you to extend your reach, to get your sample and not lose your sample container. That's usually the hardest part. You don't want to lose your sample container. And here you can see this is the Tygon tubing. So it's real rubbery. It goes through the pole, and basically you can pull it and it holds that bottle tight. Sample preservation. So for most of our samples, BOD, TSS, we put them on ice. The whole point is to have the sample stay as it was when we sampled it. Some things we want to inhibit bacterial growth. So we will change the pH to inhibit bacterial growth. And some things we want to do what's called fixing, which means we don't want the ratios of components to change because the water warmed up or cooled down or did this or did that. And so different chemical preservation methods are used, or physical preservation in the change of temperature are used to ensure that the samples are representative of what was actually sampled and they didn't change while they were in storage. And so these are common sample containers. You're looking at glass jars, amber bottles, plastic bottles. Again, all different types of sample containers. And this was that chart. So somebody asked about holding time earlier. So here you can save this. I had this pinned on my wall for the longest. Notice most things can use plastic or glass. Where you can use plastic or glass, people prefer to use plastic. You don't have to worry about it breaking. You don't have to worry about this, that, the other. Very flexible, so on and so forth. Oil and grease. This is a specific one. Oil and grease must be. It must be sampled in a glass jar. Now, I was reading one of the comments and they mentioned that you can composite oil and grease. I'm pretty sure you cannot composite oil and grease. And or according to standard methods, or the method that is referenced in CFR 136. And the reason you should not composite oil and grease is because, like everybody knows, oil sticks to the surface that you have it in. It's municipal, it floats. So as the water's poured off, it sticks in the container. So oil and grease is sampled in a wide mouth jar. That way you can get as much of it in the jar as possible. And the lid is lined with Teflon. That way the oil and grease will not stick to the lid. The reason it's in a glass jar is because when they do the analysis, they dissolve it with hexane. And that's how they get all the oil off the sides of the container to get an accurate measure of oil and grease. So in the field, we'll preserve it with hydrochloric acid or sulfuric acid to a pH of less than 2. It has a 28-day hold time. That means if you're shipping it across the country, taking it to your lab, they have 28 days to do the analysis. If the analysis is not done within 28 days, then it is out of its hold time. If the pH is not less than 2, then it is not preserved properly. But oil and grease must be collected in a wide mouth glass jar. It cannot be composited via automatic sampler or I believe any other method. So the reason you can't composite it again, it sticks to the surface. So imagine if I was sampling it, all the oil and grease would line my tubing and none of it would actually make it to my composite sampler. And then it would impact every other sample taken after that using that tubing. So oil and grease, don't composite it. Use a wide mouth, and wide mouth, you should be able to take, the mouth should be the width or near the width of the entire jar. And usually we use a 1 liter glass bottle. So that's a pretty wide mouth. You should be able to stick your fingers in or touch the bottom of it as a rule of thumb. Okay, yes.
Yeah, if I could ask, kind of related to where you were just talking to, Jeffrey Rollins has asked a question. If your permit requires a 4-hour composite, could you instead collect a 24-hour composite for A, better representation, and B, meeting the hold time before the lab can pick it up?
I would not. I would follow what the permit says. Talk to your permit writer to see what they recommend you do. You can always collect a process control sample. That way you have an idea of how your plant is performing and get better representation. But your permit writer wanted a 4-hour sample for a reason. So talk to your permit writer to make sure you're meeting what their needs are. All right, if we have those clicker questions, let's go ahead and put those clicker questions up.
We'll call them poll questions here.
Poll
But
questions. All right.
yeah, that's a whole nother. All right, I'm going to put one up right here. This is launching it, and I don't think you'll see it, but everyone else should see it. So
The
which
poll
one?
is open.
I will read it. I don't know if you're seeing it, Cornell, but it says which one of these is not a type of sampler: continuous, peristaltic, time composite, vacuum. And we'll give people some time to, I see, I can see people responding. We'll give them a couple, just quickly, if you guys would respond in the next 30 seconds or less before I close it. And I'm seeing that we have only 18% of the people voted right now. I think if we get to 50%, I'll be happy. So those of you that are actively on your computers, if you please respond quickly. Okay, I'm going to close it in
All right.
5, 4, 3, 2, 1. So I'm closing it.
Okay.
And
So go ahead.
I'm going to share it. And so the responses were such, continuous is 18%. This is how people responded. Peristaltic, 17%, 34% was the highest one. Time composite and vacuum was 31%.
So the correct answer was time composite. So we're talking about types of samplers. You have a continuous sampler, which will sample continuously. You have a peristaltic sampler, which is the pump that it's using. Remember, the continuous one is the dipper. The peristaltic is the one with the wheels that spin, and the vacuum is the one with the pump that pulls the sample up like a piston. So time composite is a method of sampling. Remember, the methods are time and flow. All right, let's keep going. Next one.
Okay, next one coming up. I will launch it now. And this is which of these is not a method of sampling. So if people would quickly, I'd like to get through these and move Cornell along. So we'll give people about 30 seconds or less. Ready, it's been 14 seconds. In 15 seconds, we're going to, might have to give them a little bit more time. I'm only seeing 2% of the people having engaged right now. I'd like to get at least 25 or 50%. So those of you who just responded, if you quickly respond, I think some people are thinking. That's good. Okay, we're getting there in 4, 3, 2, 1. I will close it. We got 50%. That's great. And now I will share it. Okay. Are you able to see this, Cornell?
I am. I can see the results. So 70% said in situ. That is great. So again, when we're talking about not a method of sampling, grab is a method. Automatic composite, that's a method. Manual is a method. In situ is a way to measure things. So you don't sample in situ. You measure in situ. And somebody had the question about their pH meter. Again, not covered in today's topic, but your pH meter doesn't have to be certified by the state. The thermometer that you use must be NIST traceable. Your pH meter, now your state may say it needs to be certified, but there's nothing in standard methods or in the 40 CFR that says it has to be certified. So again, your state may say it needs to be certified, but 40 CFR does not say that. But however, you still need to keep your records of calibration. You still need to keep all of those things. All right.
You want the next polling or you?
Yep. We're going to do all 4 of them.
Do all 4 of them? Okay, great. Here comes the next one, everyone. Time composite is a sample consisting of discrete samples collected at a rate proportional to flow. True or false? And people are starting to just respond. Got 2% of the people responding. I think there may be just a time delay between sending out and getting the responses.
Okay.
We are at 10%. I'm going to give people another 10 seconds and we'll move forward. 5, 4, 3, 2, 1. All right, closing the poll. We got
All right. Yep, and you are correct. The answer is false. A time composite sample is made up of discrete samples spaced out at regular time intervals, not flow. All right. There was a question that came up. It says, if there is a continuous monitoring requirement, but the continuous instrument is unavailable, what manual sampling approach is acceptable? If it must be continuous, there really is no manual sampling approach. So again, go back to your permit, look at what is defined by continuous, because continuous could be a dipper where it's 5 mils continuously, or continuous could be, every hour on the hour. Again, we're talking a time composite, or you really should go back to your permit or talk to your permit writer and see what they really intended.
So I put up the next polling question, and an oil and grease samples must be collected in a container that has a wide mouth and a Tygon lined lid, rubber lined lid, Teflon lined lid, unlined lid. So give people a second to respond here. I noticed that the first couple of seconds takes a long time to get anybody responding, and all of a sudden it jumps quickly to all those who voted.
Well, that means people are taking the time to think about the question before they respond.
Yep,
I'll take that.
I certainly hope that's the case. So in 3 seconds, we got 50%, and last time we had a 60%. I'm going to close 2, 1. All right, closing and sharing.
Okay, so yes, the majority of you are right. It must be in a Teflon lined lid. Again, we do it with Teflon. That way we can get the oil and grease off. Teflon is a very resilient, very stiff material. It is not really subject, we'll say not really. It's difficult to dissolve it in acids. It's very robust. It's less porous, so it doesn't interact with organic molecules as much. So we use Teflon. Again, it's slick. It keeps the oil and grease from sticking. What does stick, we can easily get off to get an accurate measurement. So Teflon lined lid is the correct question. All right.
Cornell?
Yes.
Could I interject a question for you?
You sure can.
Jolene Montoya asks, most of our bottles come from the lab with preservatives already in them. Do you have any tips to do grab samples without losing the preservative? And consider this also in terms of a fast-flowing effluent.
So let's see. It depends on what you're sampling. You can always transfer the sample. So let's say you had a large bucket. You can, if the bucket is clean, you can collect your sample in the bucket and pour it into your smaller containers. This is acceptable with the exception, and again, these are for samples, not measurements. DO, pH, all of those. pH, you can do that with. DO really should be measured in situ, because unless you can collect it gently to not introduce any air, you really should measure DO in situ. pH, you can collect it and measure it within 15 minutes. But fecal coliform, that one must be collected in the container that it's in. And do not rinse this container with bleach. Don't try to clean it out and put the preservative back in. Don't do that. The lab sends you a container. They want the sample collected in that container. So in that case, again, I know that that little tablet on the bottom just likes to wash out instantly. Catch it at the edge. That's a technique that you're going to have to develop for yourself. But I would say just, catch it at the edge and try to fill it up slowly. Just take your time. Haste makes waste. My great grandmother always said that, and I've proven that over and over. And I'm sure a lot of you have too. Haste makes waste. All right, let's keep going because we have a 15-minute video and I want to make sure I get you out of here as close to on time as possible. All right, records monitoring. Again, you need to know who, what, when, where. The exact date, the exact place, time of sampling and measurement. I need to know who took it because if there's a problem consistently, we've had this when we do inspections. I look at who's taking the samples because the same person might be taking the sample wrong every time, and that might be the cause of the problem, is that the sample's being taken improperly. So we look at who took it. We look at the dates things were performed. We looked at who took it. We look at the technique used. So again, from Missouri, show me how you do this. I was at a facility and a guy was calibrating his pH meter. And he told me how he did it and it sounded perfect. And I was excited, so I just said, show me. And when he showed me, there was one button he kept forgetting to push after he did each calibration. So instead of doing one 3-point calibration with the 4, 7, and 10, he did 3 1-point calibrations because he forgot to push the equivalent of next, and he hit save instead. So there is a big difference between a 3-point calibration and 3 1-point calibrations, which eventually equals a 1-point calibration at the last item that you calibrated. So show me. Document, chain of custody. Just like you get a tracking label or a tracking, everybody's at home, everybody's shipping packages, you get that tracking label and it says it started in New Jersey and then it made its way to California and then it bounced over to Texas before it reached my house here in Atlanta. And I feel good knowing where my package is. Well, your sample, we need to know where your sample is too. Because if something happens to it in transit, we want to know what's going on. And the chain of custody that goes with it shows us who touched it. So if something happened in a particular lab, then we know that all these samples that this lab touched are suspect. But we can't do that without the chain of custody. So the do's and don'ts, common deficiencies. Less than 6 degrees C, not 60 degrees C. Less than 6 degrees C. Not preserved, improper aliquot volume, collected, not collected, proportional to flow or according to the permit. Sample tubing is not clean. You're going to see this here in a minute. Your sample tubing should be clean. Influent samples collected upstream of implant recycles. So that means if you have return activated sludge or if your drain from your trash bin drains back to your headworks, when you take your influent sample, it needs to be upstream of that. Because I don't want anything that comes from your plant to influence your influent sample. So sample tubing was positioned along the wall. Again, there's no rule or hard fast law that says you can't do that. But if you do it, you might end up with excess solids. Improper sample container. So either plastic or glass using the wrong one. And I'll also say improper size. Because if I review your sampler programming, and it says you're pulling 100 or 200 mils every 15 minutes for 24 hours, but you have this 2-gallon container inside there, I know that you're probably not sampling. Or half your sample is going to end up pouring out on the floor. So know how much volume that you should be sampling and get the appropriate size container and the appropriate type container. The temperature of the refrigerator, you have to document this. You really should document this every time you go to collect your sample. So if it's 24-hour, this period, that period, you want to document what the temperature was when you opened it. Do this first because the thermometer, when you open that fridge, the temperature will rise, and your thermometer, when you go to read it, it may be beyond the 6 degrees C. And we're not into falsifying data. What you see is what you write down. So whenever you go to collect your sample, write down the temperature of the refrigerator. If your sample is in a portable container and you just have ice around it, then you document that you had ice or ice was present. A little bit of ice, a lot of bit of ice, write it down. And then there was no documentation of sample collection times. If we don't know when it was sampled, we don't know if it was sampled. And then if you have 2 chlorine contact chambers, so some large facilities have 2 chlorine contact chambers because they go to different locations. They might have a reuse, or they might have a city distribution, or they do something else with it. They send it to an industry. Well, we want to know what the whole influent is. So find a way to put those back together or sample before you split them. And then sample oil and grease using a plastic container, that's a no-no. Fecal coliform, you can't collect it using a dipper and then transfer it into a sterile container. You can't do that. You want to collect it in the container that the lab gave you that they're going to accept. Now, if you have preservative that's separate and you have sterile containers, you can always use the dipper and fill up your container and then add your preservative after and cap it, but you're not transferring from one container to the next. Samples for volatile organics were collected using a peristaltic pump. You can't do that. Volatiles are direct in the container, or they're collected. There's a method for collecting them. There's tips and techniques, and we can talk about those. Basically, it's like a straw. So we'll run the sampler, but we'll disconnect the tubing and pinch it. Kind of like if you were sampling your friend's milkshake, you'd stick the straw in and then pinch the top of the tubing, or put your thumb over the top of the straw, and then you let it go, and it goes right in your mouth. It slides right on out. Instead of sliding into your mouth, we put our sample in our sample container. So that's the method that we use for sampling volatiles, but you cannot pump them. Samples for volatile organics were collected. Oh, we covered that. So quality control, this is important. So you have split samples, equipment risk blanks, preservative blanks, and trip blanks. Split samples. You have split samples and you have duplicate samples. So a split sample is when you take the same sample and you share it. This is commonly done by taking 2 containers and pouring some in one container, some in the next container, and you go back and forth, or amongst however many containers, until they're all poured equally. That's a split. A duplicate is a second sample at the same site within 15 minutes. That's a duplicate. It's a second sample at the same site within 15 minutes. So if I want 2 volatile samples, or 2 metal samples, I dip my first bottle in, I fill it up, and I dip my second bottle in, and I fill it up. And I label, one is my sample, one is my duplicate. So splits and duplicates, important to know the difference. Equipment rinse blank, that's just when we rinse the equipment out. We want to make sure that our equipment is not adding any contamination to our sample. Preservative blank, in the old days when we wouldn't buy standard preservatives, we would make them up in the lab. Well, we want to make sure the preservatives are pure. So we take some DI water and we add preservative to it. We put the lid on, and we want to make sure that the DI water is clean and the preservative isn't providing an influence on our sample. And then trip blank. This is mainly if you're sampling like mercury, things that are very sensitive. What you'll do is you'll take your trip blank, and it goes wherever your samples go. So if you open your sample, usually your trip blank is the first bottle that you open, and it's just an open bottle at this point. It has DI water in it, but you open it, and then you do all your work on your other samples, and then you put the lid on your trip blank last. So it's going to catch anything that was deposited from the air or the surrounding environment that could have contaminated all your other samples. And that goes wherever your samples go. And it's treated the same as any other sample. And then safety. Don't do this. Don't do this. Samples are important. I like to get representative samples, but don't do this. This is not the way to do it. I want everybody to go home safe. And as a rule of thumb, I'll close with this. When you go to a treatment plant, remember the railings are there for their insurance, not for your protection. I was at a treatment plant and the railings were on the punch list. A lot of them had not been finished bolted down. So they rocked and they tilted because some of them were very loose. So I remind folks, the railing is there for their insurance, not for your protection. Don't lean on them. All right. Let's get a few questions going.
Okay, hey, Cornell, a quick question. What about two separate composite samplers set up at the same location, sampling at the same time? Would they be considered duplicates?
Yes, those would be duplicates because they're not coming out of the same container. That's not a split. That's a duplicate. That's another way of doing a duplicate. So think about a duplicate like this. If I have two milkshakes, that is a duplicate of what's in the milkshake machine. But if I want to share with my friend, I take one milkshake and I pour half out and I keep half. That's a split. It came from the same container. So I could say this is a duplicate of what was in my cup. I'm sorry, this is a split. Excuse me. This is a split of what was in my cup, as opposed to a split of what was in the machine. It's a duplicate of the whole.
Thank you, thank you. One other question. A number of oil and grease questions came in. I answered most of them, online. However, somebody asked, okay, and I'd like for you to explain, the circumstances around this. Someone said, well, they get duplicate amber glass jars and they'll lower one with a rope, collect the sample, and then put that into another glass jar. Could they do this? Is this acceptable?
For oil and grease?
Correct.
No. Oil and grease has to be collected in a wide mouth glass. Yeah, no, you can't. And you can't split oil and grease either. So
right,
you have to collect that. Usually that's collected in the container, like a fecal that it's going to be analyzed or shipped to the lab in. So you can't split oil and grease.
Is this in part due to the fact that when at the lab, the method requires a hexane rinse of the sample container?
That is exactly right. That's why you can't use plastic. But on site, it's because the oil and grease will stick to that original container. So whatever number you're getting by transferring it, it's going to be less than what the sample was, because there's still residual oil and grease left in that first container that the lab could not rinse and get out when they got the second container.
Thank you.
All right, everyone. I would like to thank you for participating today, and we'll be continuing to answer questions. So if you hang out a little while, hopefully we can get to your question if we haven't already. And again, if you have any questions of me that have not gotten answered, you can feel free to email me. You can reach me at Gayle, Gayle, .Cornell, just like the university, Cornell. That's Gayle, Gayle .Cornell, Cornell, at EPA.gov. So feel free to email me. Yes.
Let me add that we have people in the background responding to the questions that are being texted in or emailed in to us, and that you said you'd spend a little time looking at some of those post presentation. So we'll get to as many as we can, but we can't promise we'll get to everyone's.
Correct. Yes, and I'll add to that, the presentation is available. It should be able to be downloaded right now, but unfortunately, due to a lot of concerns that management has here just in vetting, we don't share the videos. So unfortunately, I cannot share the video with you, but you can watch it. Or you could watch it here, hopefully for those who are able to watch it. I believe some firewalls made it unavailable. So you should be able to view the presentation, listen to the presentation, but you will not be able to see the video. All right, if there are no other questions for me, comments for me, Peter, we'll start answering questions in the chat.
I think that's good for now. And we can ask
sharing the video. If you want to go back to a picture in the presentation while we answer questions.
Sure.
All right. And Cornell, I have a question from Steve Hood.
Okay.
And he asks if there's a reference for the prohibition of transferring from a clean container to the sample container for fecal coliform.
See standard methods. Standard methods, I believe, is very clear on that, but definitely see standard methods. Also talk to your laboratory.
Thank you.
And just so you know, on fecal, that has an 8-hour hold time. That's not 8 hours for you to get it to the lab. That's 8 hours for the lab to analyze it. So you really should wrap that one up as soon as possible, get it to the lab as soon as possible, so they have time to do what they need to do and still meet hold times.
Okay, Cornell, I have another question.
Sure.
What document would state that VOCs cannot be collected using a sampler pump into the VOC container as a grab?
So again, if you look at standard methods, it doesn't say that it cannot be collected using a pump. I don't believe it says that specifically. However, it says that it needs to be collected in the container. It'll be analyzed in with 0 headspace. And those containers do have preservative in them, so you have to be really careful about it. And I know it's really difficult to do. But if you know how a pump works, it creates a vacuum. And so that vacuum is going to pull the volatiles out of solution. It's the opposite of what happens when you open a bottle of soda. So that's why you can't use any pump or any suction to sample a volatile.
Thank you very much.
Mm-hmm. And let me correct myself here. I believe I mentioned you can't transfer it. You can transfer volatiles. I'm sorry. You can transfer volatiles. You can collect those in a bucket. Just be really careful and don't cause any turbulence. But preferably, you want to collect those in the container that they give you, because again, those are those 40 ml vials for the volatiles. They require 0 headspace. And once you close them, do not open them. So you want to fill them up until they have a meniscus. You can add a little bit of liquid in the cap, add a little bit more, and close them. You cannot close them if they're hot. I ran into this at a facility. If they're hot samples, you cannot close them and put them on ice for them to cool down and then open them up when they've condensed a little and there's a little bit more space in there and add more. You cannot do that. You have to close them, you have to fill them up, close them, and seal them tight. If you're worried about air getting inside, you can always take wax paper or like the wax wrapping and wrap it around the cap to make sure it's sealed nice and tight. Because those septums should be create a vacuum seal, so no air or water or anything can get into them.
One other question from Joe Braun. He asks, is there any drawback to ensuring representative samples if your collection strainer, your nozzle, is after the bar screen? Is the sample still representative of the influent?
That's a tough one. Depends on what you're sampling for, and it depends on how fine your bar screen is. Now, if your bar screen is acting like a grit chamber, that's a different story. But if you have, a 1-inch, 2-inch bar screen, you should be fine, because all you're doing is getting out the bigger items, things that are bigger than a 1/4 inch, because those wouldn't fit in your sample tubing anyways. So if you had eighth inch bar screen, I would say that would interfere. But again, 1/4 inch or larger, you should be fine.
Hey, Cornell.
Mhm.
What kind of oversight by the certified operator is needed during sample collection?
So I saw this question and I wasn't sure what it was asking, so I'll answer it 2 ways as I understand it. If you have a certified operator, they don't need oversight when doing their sampling. They should know how to sample properly according to their permit. And I'll say if an operator is teaching someone, they will have to determine how much oversight that person needs. But there is no requirement, to my understanding, that says an operator needs oversight. However, all that being said, we're talking daily operations here. Now we're talking when your inspector or an EPA inspector comes out, we want to see how you do it. So we're going to watch you sample to make sure that you are doing it according to the standards and methods and getting a representative sample. And so we are going to make comments on, hey, there's a better way of doing it. If there's a better way, or there's a safer way, like the picture we saw at the very end of my presentation here, like this picture here. If you were doing that, I wouldn't even let you get that far because that's not safe. And I want you to go home to your family. So we would make recommendations that way. But outside of collecting a representative sample or how it goes in the container, I do not believe there's a document that says you have to use a 10-foot pole with this, with that, with this, with that, or you have to use a bucket. And I don't think there's a document that says that.
Cornell, do you see that there may be variations from state to state telling the permittee when the sample time is to be, I guess, recorded for a composite sampler? It may be that some states might require the sample date to be the date for which the greatest volume of the sample was taken, but it seems that most states or EPA require it to be the time of the last sample aliquot collection.
That's more common, the time of the last sample aliquot. But again, talk to your permit writer, talk to your lab. This is just one of those things. Again, this is wastewater. This isn't a chemical plant where the exact time down to the second matters for you because you're producing a drug. At wastewater, we deal in big batches, things that don't change at the turn of a hat. Now, you might have a clarifier that burps, but even that's going to turn over a lot of flow over a sufficient enough time to be notified, collect a sample, and do something about it. So whether you mark the beginning or the end, again, talk to your permit writer, see what they specify, make sure you get it in documentation, get it in writing, and then go with that. But as far as an inspector, when I come out, if I see you write down the start time, as long as when I look at all the data, they all say the start time, I'm not going to quibble about that. I will say, while we were mentioning documentation, I forgot to mention this. Being that this is the digital age and a lot of our lab analysis are emailed to us, email is not a good record-keeping practice. So make sure that you download those emails and you have them readily available. So if they're on a network drive, on a portable hard drive nearby, they need to be readily available for the inspector to look at them. And because this is the digital age, I also recommend off-site backup. That way, if something happens in the treatment at the facility, or let's just say your computer crashes, you have a backup someplace else.
Cornell, I have a question. Should temperature in an automatic sampler be maintained at or below 6 degrees Celsius?
In a refrigerated sampler, yes. It should be maintained less than 6 degrees Celsius. If you're looking at the video, we were opening and closing that door. And so the temperature, you see how fast the temperature rose. When we started at the day, I think the first time we opened the door, it was at -3 degrees. Not -3, it was at 3 degrees C. So it was pretty cold. But by the time we had been in and out of it, I think it got up to almost 9 degrees. So that's another reason that as soon as you open the door, the first thing you want to do is check the temperature. Now, if you have a portable sampler and it's on ice, like I mentioned earlier, the exact temperature isn't as much a concern. What we're looking at is there ice present? Is the water cold, or is it warm, or is it hot? We want to know that it's in the process of being cooled, because we understand that a sample that was just deposited is not at 6 degrees C. It's at the temperature from the body of water where it came from. And in northern climates where you have snow, if your sampler is outside, you might need to insulate it to keep it from freezing. So that's another challenge that you'll come across. And I've seen people just take attic insulation that you get from Home Depot, put it inside a garbage can, and use that as a cover for their sampler.
That's clever.
One follow-up to that, I'm noticing somewhat related. It says for automatic sampler, do you accept the, what is it, the NIST thermometer
Yes.
yes. In a bottle of water to verify temperature that the sample is maintained at? Do you accept the thermometer reading only the air temperature, reading of only the air temperature?
So you can read air temperature or water temperature. It doesn't matter. The problem with air temperature is, let's say I go in and I open it up and I pull it out and somebody asks me a question. Well, that is going to heat up faster than if it was in a bottle of water or a bottle of alcohol. Now, as far as NIST, yes, that thermometer needs to be NIST traceable. It does not have to be your $3,000 NIST thermostat or thermometer, but it will have had at one point been compared to in the last year to a NIST thermometer, and there needs to be a record of that that says this thermometer number blah 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 was compared to this NIST thermometer blah blah blah, and they read this much apart.
Cornell, I'm going to suggest that we finish in about 3 minutes at the 3 o'clock hour. So whatever last minute questions we have, that would be great.
That's fine. So when you document your temperature going forward, you'll have to remember that this is this much off from the NIST thermometer, and that needs to be documented on or near the thermometer. You could just take a piece of tape and wrap it around the top, make like a flag, and just write +3 degrees or minus however degrees to know the difference that you need to take into account for the NIST thermometer.
Well,
And
Cornell, I just want to let you know that we've had just many positive comments in the chat box on your presentation.
Oh, thank you.
And I would like to also compliment you on just a marvelous, very comprehensive sampling presentation. So thank you very much.
Thank you.
Well, at this point, well, I guess we'll stop with the questions, and I want to compliment all of you guys, including Laura in the background who's helping with the webinar, and Cornell, you did a wonderful job, and I really was impressed by the video that you guys pulled together only yesterday with Chris. So the guys who are listening, that was done yesterday, so it was pretty impressive. And I want to thank Chris, who's also helping with the questions as well as the video, and Juan Ibarra, who I mentioned earlier, who's from our Dallas Region 6 office, have been helping us today. So it's been a real joint effort, and I really compliment you all for your help and putting this webinar together today. So what I'm going to do is I'm going to end the webinar. If there's any last minute, I'm hearing a reverberation of myself. Thank you, Cornell. If there's a last comment you have, Cornell, and then we'll end the recording. And then if there's anything else, we can talk offline.
I too would like to thank Peter and Laura and the team. They put these on for the past, 2 years now? We've been doing these. And so I really want to thank you for always including us. I would also like to say again, if you have any questions or you just want to pick my brain about something related to sampling or flow measurement, just reach out to me. Last name Gale, Gayle .Cornell, and that's at EPA.gov. And if I don't have the answer, I will find somebody who does have the answer. I'm good at that part. All right. Have a good one.